We have the strut mounted in the vise. Before I start taking anything apart, I just wanted to point out, maybe we can get a close-up over here, that there is dirt all over the strut after I took it off the vehicle, and you don't want any of that getting into the strut, especially on an older strut like the STX prior to 2016 and the older STs. We're going to clean it off, and then we will come back and start the disassembly process. I did my best to clean it off. There's still some corrosion buildup from the special sleeve that it was mounted in, and the strut is 7 years old. It's seen a lot of salt. I have it mounted into the V-blocks that I made, and I'm using a strip of leather to help grab it because it'll slip in the vise otherwise. And just give it a nice solid hit, and it should break that loose. I haven't tried to break this loose yet, so it's probably going to be tight. Okay, there we go. Now this might spray at me because I moved the shaft, so I'm going to use the rag to prevent it from spraying all over me. Alright, pressure's released. I should be able to thread off the rest of it by hand. Now, sometimes when you take these off, some of the rebound parts in the very bottom will stay in the very bottom. This one came apart, so this is exactly what I'm pointing out. The damper case on the very end came off, and it's still down in the piston shaft. This is supposed to have an assembly with a floating valve and a spring attached to it. That's going to be down inside, and I'll have to pick that out. But I'm going to set my rebound sleeve in my bucket. Hang this so it can drip into my pan. And I'll go ahead and pour this out. I might get that part out when I pour out the oil. And something I did want to point out here, see how the oil's all green and nasty looking? That doesn't necessarily mean the oil's bad, it just means that the oil was reacting with whatever brass parts that may have been inside the strut. In this case, the green oil might actually be from the top end because the strut had an internal leak. But it's from reacting with the brass that makes it turn green like that. So I'll remount this in the vise. Now that that's mounted back into the vise and I have my parts, it looks like the damper case actually did not come out. I got my spring seat, my metering plate, my Belleville springs, and the spring for the spring seat, and the damper case and the floating valve are still up inside the piston. And just keep in mind when you do this on the bottom end, there's still oil trapped in the top, and in order to get all of it out, you'll actually have to cycle the strut. I'm going to try to do this without being too messy. If you're ever refilling the lower end on the strut, you'll have to do this to get all of the oil out, so that when you put the proper mount back in according to the manual, you actually get all of it out. Otherwise you'll overfill it. This one didn't have too much in there. Cycle it a few times and it looks like, no, that wasn't the part. Alright, so we have the damper body that's still stuck up into the piston shaft, so what I did is I got this hanger. It's got a plastic coating on it to help protect the parts that I'm going to be pulling out. Just bend a small L shape onto the end. I'm going to shine a flashlight up into the piston shaft and pull it out. Now I don't want to damage this, so I'm actually going to catch it when I pull it out. There we go. And here we have the damper body, and this matches with the metering plate. This part is the part that actually controls the rebound damping on the older design. And there's a shiny surface here and one on the inside, and on either side of that V groove. That part right there cannot be damaged. If it is damaged, the rebound damping won't work. And this is also why, if the oil is contaminated, it won't work, because whatever debris is in the oil will get lodged in that V and it won't move, and then your metering plate won't seal. So we're going to set that aside, clean everything off on the bottom end, and the next thing we're going to do is take apart the upper side. I try my best to situate the strap wrench so that I don't damage the anodize, and I like to grab on between the ORI logo and the bottom ring on the cylinder. Gives me the best bite without tearing up my wrench on those pockets that are milled into the lower cap. Just like that. Now, when you're taking apart or removing the upper cap from this, hold on to the bottom down low on the cylinder so that it doesn't tip and spill all the oil that's on the outside. Save you a little bit of a mess. There probably won't be much oil in this strut. Like I've mentioned before, this is a strut with a leaky internal seal, so a lot of the oil has actually transferred to the bottom, and then I drained a lot of it out through the valve when I was messing with it and repressurizing, so there probably won't be very much. But I'm going to take this out of the vise and pour whatever oil out that is inside the strut. Not much. Don't lose that O-ring. When I remove the cylinder, I'm going to want to grab onto these threads. I'm not going to want to grab on so tight that I can crush the cylinder, because you can crush the cylinder if you have a tool like this. The threads will be the strongest part to grab onto. Be careful when you're grabbing on to the lower cap without the outer cylinder attached, because you don't want to crush this lip right here. So I'm going to grab a little bit lower to miss the lip. Let's see if I have that tight enough. This is actually a new style cylinder that has a flange and an O-ring that presses the O-ring into the lower cap here. And this groove is one of the areas that can leak if you have a leaky strut or an internal leak. The other part that can cause an internal leak is actually this upper seal as the most common cause. If you're looking for an internal leak, you're either going to measure this to see if the groove is the right size with a set of calipers, or you will look at this seal and inspect it for damage. It doesn't look like this one is damaged. A lot of the times you can see a wavy edge. If you look at it from directly above, you can tell if it has a wavy edge and it'll have notable heat damage. This one doesn't look like it does. It looks like it has a nice sharp edge. And if you remove your glove and actually use your fingernail, you can work your way around the edge of the seal. To see if there's any cuts or nicks that grab your fingernail. This one doesn't seem to have any of that either. The easiest way to remove the piston will probably be to use an impact gun and the tool that ORI sells for this purpose. Spanner wrench for the piston. Some of these pistons can be really hard to remove, and if you have one that is difficult to remove like this, you may have luck using a little bit of heat around the piston shaft, right about here. And I'll go over a little bit, I'll give you a few tips on reinstalling these pistons so that they're not impossible to remove, and that's just a matter of how much Loctite you use. Luckily this one came off without destroying everything. But if you do end up destroying it, they can be replaced. Now that the piston is off, I can remove my lower cap. Oops. And the strut will be completely disassembled aside from the seals. Now that I have the piston off, I'm going to go ahead and remove the seals. When you're removing the seals, you want to be careful not to hurt or damage the inside sealing surface that the seal rides on, because that will also cause a leak. There's been a couple of people I've worked with that have actually caused internal leaks by scratching that inside surface. And I will destroy the seals when taking these off. I have new ones to replace them with. I'm not worried about it. There's the one. I'm not really worried about hurting either one of the seals, so I'm just going to cut this with my snips. Do a quick visual check just to make sure you didn't do any damage to the inside seals or scratch it with the tools that you use to remove them. looks like these are good. And another thing to check for is make sure these seals are actually in good shape from the factory. If there's any chatter on this groove, it's a good cause to replace it. These look shiny, and you could even measure these if you need to. The next thing I'm going to be doing is removing the wear band, the O-ring. Once again, being careful not to hurt the inside sealing surface of the O-ring. And then the bump stop. The only way to get these bump stops out is to hold on tight and pull. It will cut the square O-ring inside, but once again I have a replacement for that, and I'll show how to put that back in properly. There will be a piece of rubber inside that you'll want to get out. That's the piece that it's sheared off to get it out. If there's any marks on my steel bump stop after I'm done, I'll file those off smooth so that it doesn't bind on me. And there's the return spring for the bump stop. Go ahead and remove that old O-ring. Next, I'll be removing the rod seal from the inside of the lower cap. In a lot of cases you won't have to do this because it's not always necessary, but in order to show a full rebuild, I'm going to be removing this rod seal and also the wear band, which is real easy to take out. You just grab onto it with your fingernail, pull it out. And to get the rod seal, just like the piston, I'll be using my pick. I'll be destroying the seal, and I'm going to be very careful not to scratch the inside sealing surface on the lower cap. Right now I'm cleaning up some of the parts. I've already cleaned the piston shaft out over here on the table. It's important that all the rebound damping parts are cleaned really well before reassembly. And before I start reassembly on the rebound damping parts, I'm actually going to take this apart the rest of the way. And to get that vent tube out, it's actually just press fit into the lower mount. It should pop right out if I clamp it into the vise lightly. That like that, it'll come right out. And then I can remove my lower mount. I'm not too worried about scarring up the shaft right here. It does need to be smooth, but if I leave any burrs on there, I can clean them back off with a file. Crescent wrench. Actually, wrench. Go ahead and take this off. The V-groove in the vise shouldn't leave any burrs on that. I don't think it will. I didn't grab on that tight. Part of the reason I'm taking this apart is so that I can show everybody the proper amount of Loctite to use on these threads and the threads on the damper body side. And it's also very important that we go through and make sure all the Loctite, all the old Loctite on this thread and on this thread is all cleaned off. You can see all that flaking off. that can't be there when you put it back together, otherwise it'll make the rebound damping fail. So I'll clean that out really well. I'll clean both of these threads out. If I have to use a little pick, I will. And I'll clean out the threads, the inside of the tube, this part, the piston shaft, and all of the rebound damping parts that I took out earlier with brake cleaner before I put them back together. This is the steel vent tube. It comes in the newer struts, and it doesn't react with the oil and turn the oil green like I had mentioned before in the video. The best way I found to reinstall the vent tube is just to put it into the vise, and it will go into the lower mount, 0.3 inches. Go ahead and take a measurement there, a little bit less. And I measure it just so I know that it's actually gone all the way in. I'm going to be using a dead blow hammer to reinstall that. And you want to kind of take a look at the vent tube and make sure it doesn't slip in the vise when you do this. Otherwise you might not have the vent tube in far enough. There's not much lighting here. But I just lightly tap on the end while supporting this side so that it doesn't bend my vent tube. This one's going in pretty easily. And there it bottomed out. Now that we have the vent tube reinstalled into the lower mount, I'm going to set that aside. And we're going to begin reassembly of our draw tube parts for our rebound damping. First thing we do is take the little white O-ring that comes in the seal kit and place it at the bottom of the damper body threads. Make sure that it seats in that groove down there. And then we're going to use a little bit of Loctite. You don't want to use too much here because you don't want it to squeeze out and get onto your sealing surface of the damper body. I use really just a drop, maybe 2 drops or so. Not much at all. And then I'll take my draw tube and I'll thread that down until I can feel it bottom out. You'll feel it squeeze the O-ring out a little bit. I can feel it start engaging with the O-ring there. And I'll lightly clamp onto the outside edge of the damper body in the vise here. You don't want to grab on tight because you don't want to distort the surface. And you'll feel it bottom out. You don't want to make this too tight, otherwise it will actually distort that inside edge and cause your damping body parts not to seal. So I've just got that hand tight. After the Loctite has a chance to dry, it will hold that on there and keep it from coming off, at least while it's operational. You notice that when I took this apart, it actually did come apart, but the strut was working just fine until I took it apart. I always go ahead and inspect both edges of those seals to make sure they're clean and that there's no Loctite that squeezed out. It looks like we're good. So the next thing we do is take the metering plate, slide it over the edge, make sure there's no grit in between those surfaces. Take our spring and our spring seat, and then next we use the Belleville springs, and they go together like this. So if you notice, they're dish shaped, and you want to take 2 of them that are shaped like this and the other 2 dish shaped the opposite direction, so that it looks like that when you're done. And if you look down inside, you can see a gap in between, right in the middle. Next we have the draw tube. And then we have these parts that are going to be used for calibration. I'll go ahead and thread those on now. The 2 jam nuts. and the steel one. So the next thing that I do, I want the Loctite on this and on these threads here to dry at the same time. I usually let it dry for about 30 minutes so that when I put it back into the oil doesn't mess everything up. I'll use a little bit more Loctite on these threads. Oops, that's actually too much. You don't want to use too much because it'll come out and flake off and cause issues with your rebound damping. Looks like I have just enough left over in there to work properly. So now we're going to insert the rebound pin into the lower mount and then take our rebound damper assembly and thread that into our lower mount. Now I have Loctite on those threads, just enough for that to work, but not too much that it's going to squeeze out and flake off into my oil. Next we take our floating valve and our damper case and thread that onto the bottom after we put our O-ring on. There we go. Make sure that spring's as straight as I can get it. And I'm not going to tighten this down as much as I can. I'm just going to use hand strength, tighten it down. Should be good enough. You don't need to use any more than what you can do with your hands because you don't want to distort the surfaces on the metering plate and damper body. And like I said before, the Loctite should hold everything in place while it's in operation. And the last thing that we need to do is install one of our O-rings. The seal kit comes with two identical sized O-rings, one for the lower mount and one for the piston. That goes right there. One goes here and one goes right there. There's another O-ring that commonly comes in the rebuild kits that's slightly bigger, and you want to be careful not to use the wrong one. And when I say slightly, I mean very slightly. Just be careful and know that you have 3 O-rings that come in the kit. This one that is slightly bigger goes to the piggyback reservoir. So I'm going to go ahead and slide on my O-ring onto the lower mount. And that is complete. I'm going to hang it like this so that it can dry, and I'll let that sit for at least a half hour so the Loctite can dry properly, and then I'll come back and calibrate the jam nuts so that I have the proper gap for my rebound damping. While the rebound damping parts are drying, while the Loctite is drying, I'm going to go ahead and install the seals into my lower cap. I actually have a new lower cap that I'm going to be using, but I'm going to show how to do this anyways. I like to use a little bit of grease where the piston shaft rides inside of the lower cap to help it move better, and just a little bit right there where the rod seal goes. I try not to get any grease on the sealing surface of the rods or the rod wiper because I don't want the grease to stick to the dirt. Using our rod seal installation tool, we'll get this in there. Now you want to make sure you put it in the right direction. Goes this way. Just like that. And then the rod wiper, or the dust seal. You can squeeze this in with your fingers pretty easily. And I do have a little bit of grease in there. I'll just wipe that off. Like I said, I don't want that collecting dirt. After installing the rod seal, you want to make sure that you get a little bit more grease and grease the seal itself, just the white seal, not the dust seal. And I'll put a little bit more grease on the surface where the piston shaft will slide on the lower cap. Next, I'll take my piston shaft and make sure that I use the edge that has a small chamfer on it, and it'll help guide it into the rod seal a little bit better. The other side has a sharp edge. You don't want to use that one, it might cut the seal. So using my shiny chamfered edge, I'll work it into the rod wiper. I'll have to kind of pull back on it and lift up and down a few times to get it in. And I'll just work my way around and make sure that it's not tucked in. It looks like we're good. After you get it into the wiper, just push straight down on the shaft. And it should slide past the main rod seal. Wipe off the excess grease. Okay, so I have my lower cap installed onto the piston shaft and held into the vise. I need to go ahead and install my seals onto my piston. And before I do that, I'm going to put a little bit of grease on the inside sealing surfaces. Check them one more time to make sure that those sealing surfaces are not scratched. You don't need to put a lot of grease on these, just enough to make it so the seals can slide. To install the bottom seal, I'm going to use my tool from ORI, slide it over the threads, use a little bit of grease on the cone tool itself, some grease on the seal, and this seal has to be placed so that the backside is facing this direction. This is the seal that holds the pressure in the lower chamber. Let's go ahead and slide that on. Now we're going to install the wear band, and then we'll grease the upper seal. And install it onto the top of the piston, facing the opposite direction as the other one. Just like that. Be sure to install the other O-ring that we talked about before onto the top of the threads here in that groove, and work your fingers around it to make sure it's not twisted. Be careful not to cut yourself on the threads. Some of them can be sharp. Next we're going to install the bump piston. We're going to use a little bit of grease. On the inside portion of that bore. We'll install our quad ring onto the bump stop, and we'll have to work our fingers around it to make sure it's not twisted. Looks like it's good. We'll install our spring, and then to get the bump piston in to the piston without damaging the quad ring, I'm actually going to use a screwdriver to tuck it in a little bit at a time while pushing down on the top of the piston, just to get it started so I don't cut it when I push it in. Once it looks like it's started all the way around, evenly push down on the top of the piston until it slides in past the ledge that hold that quad ring in place. There we go. Make sure that it works, and the piston is complete and ready to install on the piston shaft. We have our piston seals installed onto the piston. We have the O-ring for the piston shaft and the two seals for the cylinder. Make sure they're facing opposite directions, and the cup side is facing up on the top side and bottom on the bottom side. And before we install it, we are going to make sure those threads are clean so that the Loctite will work properly. I'll spray a little bit of brake cleaner. I don't want to get it on my seal. And that should give me a dry thread that I can use. I've already shaken up my Loctite. Go ahead and do that again. I'm going to try my best not to get any grease on the threads as I'm doing this, and there's a right amount of Loctite to use. You can use too much or too little. Too little and your piston might come off. Too much and the piston will never come back off. And that's really about all you need. It'll work its way around as I'm threading it on. I'm going to use my impact tool again to tighten it up. And again, it's probably best to let this sit for a little while before I put the oil and everything in the strut. And I'm going to need different vise jaws to hold this in place so I can grab onto it better. There we go. That leather grabs a lot better. And now that that is on, I'm going to grease the piston seals. I'm going to lay it down fairly thick, but not too much. And this is going to help the strut slide in the cylinder a lot easier initially, especially when the struts are sitting stationary. A lot of people may have noticed that the ORI struts can be they can feel pretty stiff when you're trying to move them around in the garage. And it's because this large piston shaft with the big rod seal here and these two seals here, there's quite a bit of friction that has to be broken loose, and this grease will help it break that loose. I'm going to go ahead and put a little bit of grease on the inside of my cylinder. I'm going to double check to make sure that it's clean inside, except for that grease that I just put in there. Kind of help it along, and you can see there's a large chamfer there. So I could probably just go ahead and slide this right on. When I worked with these before, they didn't have that large chamfer there, so this will probably go on easier than I thought it would. But if it does seem like it's fighting me, I'll go ahead and, before you slide the cylinder on, make sure you get your O-ring and ring in place. Goes the other way. There, it fits nicely onto that snap ring, and then the O-ring goes right there, and I've already greased the O-ring so that it's not going to stick when it might be easier just to do it like that. I want to make sure that O-ring is actually pressed into the groove properly when you start threading this on. And it looks like that chamfer will be sufficient to slide that on, and that felt good. You want to be careful not to cut that seal or damage it at all when you're putting these together, otherwise it'll create an internal leak, and that's no good. Just go ahead and slide this ring back up. Oops. And I might have to swap out my aluminum jaws for my wooden jaws again, because I'm going to have to use those aluminum jaws of mine to tighten the cylinder into the lower cap, combined with my strap wrench. So if you look up on top here, we have the piston where the wear band is going to be placed right about here, and I'm going to grab onto it there. I don't want to grab on so tight that I crush these threads, otherwise it will cause problems when I try to install the upper cap. But I also don't want to let it slip, so it should be tight enough. I'm going to use my strap wrench, grab onto the lower cap, let's see if I have all this set up right or not. And slowly let it push that O-ring into place. Maybe I'll move this down so I can watch it better. And once it stops, you'll know that the O-ring is fully seated right there. And I'm just going to situate my strap wrench and my vice jaws, my aluminum V clamps, in a way that I can get a bite on it here. Once again, be careful not to grab onto the lip of the lower cap and bend it with your strap wrench. So I'm grabbing on just a little bit lower. Make sure that I don't do that. That should be tight enough. Okay, we have the strut mounted in the vise. It's ready for oil. We need to make sure that we get all the seals for the outer cylinder installed for the shell and also the inner cylinder. So I'm going to put a little bit of grease on the seals. It's important that this one's not twisted out of shape because it's skinny and it can get twisted when you install it onto when you install the upper cap. So get that down on in the groove right here. It's an easy one to forget, and just work your fingers around it to get the twist out of it. Okay, we should be good there. Again, checking for any chips that might be on the struts, keeping all those clean. Let's get some grease on our outer cylinder or shell O-rings, upper and lower. You don't have to have lots of grease on these, just enough to keep them from grabbing when you tighten down the outer shell and upper cap. And install our upper O-ring right there. If you get just a tiny bit more grease on the upper one, it'll help keep it in place. I already have my oil pre-measured. You can hear the bubbles. That's the oil going down into the bump stop. After filling the upper chamber with oil, remember to install your compression valve. And just to point something out really quick on this compression valve, it has 3 holes, and that is the latest configuration for the compression valve. The ones with 5, we will often use set screws to plug off 2 of the holes, and these could be modified to change your secondary spring rate if you're bottoming out too easily or if the secondary spring rate's too stiff. And this compression valve goes on top of the cylinder, just sits right there like that, and then you can put your upper cap in place. Also remember to install your upper cap O-ring for the shell and the one on the bottom. I already have a little bit of oil in here, so I'm not going to pick it up. And there's also another O-ring right there on the cylinder, the little black O-ring. Make sure all those are in place. And the compression valve itself has 3 springs and an O-ring in the middle. Now that that's all in place and my oil is in the strut, we'll go ahead and finish the assembly. And then after we finish the assembly, we're going to do a quick test just to check that everything's working properly, and then the strut will be done. Should be good. We have our older STX style rebound damping assembly on the table, ready to calibrate. This is a rebound damping assembly for STX struts prior to 2016. And to calibrate this version of the rebound damping, you have to adjust a gap between this jam nut and that steel rebound damping pin. And the factory manual calls for an 8/1000 inch gap. I'm going to make mine a little bit tighter on the 5/1000 inch gap because I like my rebound damping to be a little bit tighter. So we're going to, and something else that's important before I forget. the rebound damping screw needs to be on its tightest setting for this calibration to be right, all the way clockwise until it locks. And the screw will be in that same position when it's all the way to the right. Now that we have that, we can begin calibrating the gap with our feeler gauge. And I just get it started, and I thread this down with my fingers until it stops. And to begin, I usually get the jam nut on the back side, just finger tight. And you want a slight resistance on the feeler gauge. This is too much, it's bending my gauge. You see that? But you actually want to move it around until you find the loosest spot. And it seems like every spot on this is actually a little bit too tight. So we're going to loosen that with our fingers a little bit. Let's make it finger tight again. It's too much of a drag there. I'm going to rotate it around until I find a looser spot. Almost, it's a little bit too loose. Just needs a slight drag. There we go, I have a loose spot right there. A slight drag, and that is on the loosest spot when I turn the part around. So I'm going to leave that feeler gauge in place. Grab my 2 sets of pliers and tighten that down. They don't have to be super tight. Double check my gap. It looks like I got it right. It may take a few tries to get that right. Very possible you won't get it on the first try. And when it's right, there'll be a slight click back and forth. If you zoom up, you can see that there's a small gap there. And you can also look at the parts down on the end closer to the metering plate and damper body. There's also going to be a little bit of movement there on the tightest setting. And once again, just spin it around to make sure that you don't feel any grit in there. And that part is done. We also want to, if we created any burrs on these jam nuts, we're going to want to take a file to those or just clean them off the best we can. I'm probably going to lightly go over those with a file and then carefully blow those off with the air gun. Just to get any loose chips off of there that might flake off into the oil, because that will keep it from working. And looks like I do have some debris in the threads right there I've got to get off too. Okay. Okay, now we have our lower mount rebound damping assembly calibrated, and we're ready to put the oil into the bottom, into the piston shaft in the bottom half of the strut. Now the oil in the bottom half of the strut is actually a 10 weight fork oil. In some of my other shots in this video I had a engine oil, a 10W40 in the shot, and that's not right. Make sure that it's a 10 weight. And the Spectro fork oil is actually blue. The oil on the top is a 2.5 weight ultralight from Spectro, and it can be any 2.5 weight shock fluid. There's other brands that work well. But I have my oil pre-measured for this piston shaft. I'm going to pour it in. Alright, and if before you install the lower mount rebound damping assembly into the piston shaft, you're going to need to cycle the strut back and forth a few times to suck the oil in underneath the piston so it doesn't overflow on you when you install the rebound damping parts. And then before you put it in, just bring it up as much as you can so it sucks the oil down into the shaft and the oil doesn't come out. I have my older rebound damping assembly prior to 2016 out on the table that I just calibrated, and I can install this one into the piston shaft. However, I have the new version, 2016 and up, right next to it. This is the older one here that I just worked on. And if you feel inclined to bypass all the work of putting this together and calibrating it and making sure that it's super clean, you can just buy the new assembly from the factory and swap it out, and it cuts your work in half pretty much. It also works a lot better. It's an improved design. It's not prone to fading out and not working as well when there's a heavy load with the heavier axles and tires, and when you make the adjustments with the rebound damping screw, you can feel a definite positive effect between all the way clockwise, all the way counterclockwise on the adjustment screw. It's just a much better working design, and I recommend it. So instead of installing this one, I will install this one. Now, something to take note when you're installing this into the oil. I have this piece here. The newer design does not have a damper case like the old design does. You can see the damper case on this one that holds the floating valve and spring in place. This one does not have that. And in order to get this down into the piston properly, it's best to use a long wire of sorts and guide this spring first into the piston shaft. I'll use my hanger from before. There we go. And I want to get the hanger into the middle of the piston, into the bore in the middle. There it goes. Generally you would do this before you put the oil in, but I did not think of that. But this will still work. I'll just make sure that it has time to settle to the bottom there. And I have a way that I can test this to make sure the rebound damping is working. If it doesn't go in, you'll know right away that it didn't work, because when you test it, the rebound damping just won't work. I believe that's all the way down. And when you're grabbing onto the piston shaft in the vise, you want to grab onto the piston shaft about 1.5 inches below where the threads begin and when they end, which is about right here. And the reason for that is if you're grabbing onto the threads, especially when you're loosening the piston shaft, it will be really hard to get it off if you're clamping onto those threads. So I grab on just a little bit below that to make sure that I'm not putting too much pressure on those threads. And I'll grab my new assembly. Once again, I have this strut up as far as I can in the vise so the oil doesn't overflow on me when I install this. Double check to make sure that your O-ring is in place. And a little bit of oil wouldn't hurt on that. I already have some on there just to kind of help it seat better. Yeah, something else that you may notice that this lower mount does not look like the factory lower mount that you would purchase if you were to buy this upgrade. This one's been trimmed down to fit into a special mount. It's a special application strut, which is also the reason the piston shaft on this strut is longer than it normally would be. I've got a fairly tight grip on the piston shaft, and I'm going to use my crescent wrench and a hammer to tighten this on. So long as you have a good bite on the piston shaft, using the leather that I have pinched in between the aluminum vice blocks and the piston shaft, it should grab it fairly well. And this is my brand new lower mount, so I don't want to damage it. I'm going to use a rag to protect the anodize. Oh, look at that, it's turning the whole thing on me. And a few solid hits should make it stay on pretty well. Grip on that. That should be good enough. And the strut is put together and we're ready to pressurize it up with some shop air and test it. We have the strut completely assembled and we're ready to finish up. To do that, we're going to do a quick test to check to make sure that our rebound damping is working properly. And to do that, you can use shop air inside the strut, so long as you replace it with nitrogen afterwards. And I like to put about 40 psi on the bottom, 40 to 50. And use a little bit of pressure up on top to bring it up. Should be good. And you can move this damper screw around. I'm going to start on the loosest setting, which is all the way counterclockwise. And this should be the quickest setting on the rebound. And to show the difference between full loose and all the way tight, I'm going to turn this all the way clockwise to show the difference. This strut's working properly, so I'm going to go ahead and install it, and we have a working strut.